So moving on to the do. If we look at our inference formula sheet, as we saw with our 1 proportion z-tests, we are going to need a standardized test statistic. It involves taking a statistic. In this case, we're focused on a sample average minus a parameter. So that will be the corresponding population average. And then I'm going to divide that by the standard deviation of this sampling distribution, which is this guy here, except I'm going to have to use S, so it will be the standard error of the sampling distribution. So again, my statistic is my sample average. My parameter is my population average. And my standard deviation would be my S over root n. Since we're using S, this is not a Z test statistic, it is a T, because we're using something that is variable from sample to sample. This is called a one sample t-test or just a t-test. So I'm going to plug in all of my values here. My sample average from my plan was 4.77. The population average is what was claimed in the null, 5. My sample standard deviation was my 0.9396. And that gets divided by the square root of n, which would be the square root of 15. I do not have to compute this by hand, okay? I can just go and find my t-test on my calculator. So if I go to Stat, Test, t-test, I could enter the statistics that I recorded in the plan, but in this case, since I have the data stored in list 1, it's a little easier if I just tell it my data is in L1. My mu naught is what I said mu is equal to in the H naught, or the null hypothesis. That was 5. The list in which I stored the data was L1. Each was one measurement. The direction of my alternative, read left to right. Did I say mu is not equal to 5? No. Did I say that mu is less than 5? Yes. Remember, the direction here in your stat test t-test will be the same as the direction in your alternative on paper. They're both pointing to the left. Okay? So if I go down to calculate or draw, it will show me this left-tailed test. And this is why I like to draw it, to make sure that I did in fact choose the correct direction for my alternative. Here is what my t-test statistic value would come out to be equal to if I had computed it by hand. So this equals negative 0.99426. And my p-value gives me the area in that tail, 0.1809. The only thing I'm missing is degrees of freedom. I took 15 measurements, so my degrees of freedom is 14. Write those down as soon as you remember it. So if you remember it up here when you're doing the plan, write them down. Because t-distributions are different for different degrees of freedom. Now, was I given a level of significance in this problem? No, I was not. So the level of significance I can use is 0.05. Is my p-value more unusual than 5% chance? Absolutely not. So what's my decision? I don't have statistically significant results. I fail to reject the null. Why? Just like with our one proportion z-test, we want to link it to the p-value. So we want to say because my p-value is large, finally, what did I decide then, or what have I decided then about my alternative in context? I don't have evidence to say this is true, but put that in context. So I don't have evidence. You only have evidence when you reject. I don't have evidence to say that the average DO level in the entire river or stream is less than 5 milligrams per liter. And there's your conclusion. There's your first full-fledged 4-step hypothesis test about a claim made about a population mean. So, as you're working on your frappies and your review these 2 days, if you have any questions, do not hesitate to email me. I will respond quickly in between sessions at the conference or even in the evening. So send me an email. We want to have all of our frappies that are assigned, and the sub will give those to you. They're on your assignment sheet, done by the time we walk in the door on Monday, as well as the review that she's going to give you that you'll have time to work on Friday as well. Best of luck to you.